a shell will land are considerable. In the former Soviet Army, and even today in many parts of the world, battery officers have to carry out manual calculations using firing tables and a Pu-09 protractor or equivalent. These calculations require a high level of mathematical skill combined with a methodical approach and great accuracy, usually undertaken in a highly pressured environment. Inevitably, the pressure to produce this data under battlefield conditions can lead to human error, with potentially serious consequences. The aims of Ukrainian defense consulting in creating the UBC, or Universal Ballistic Computer, were simple: to do away with manual calculations and firing tables, to make the calculation process both easy and fast, to eradicate as far as possible the human error factor, and to create a platform with the flexibility to be used across different artillery systems. The core of the UBC is Ukrainian Defense Consulting's proprietary software programmed into a Nomad handheld computer platform using Windows operating system, certified to US military spec IP67 and MIL standard 810F. The unit, which is made by Oregon-based TDS, is equipped with GPS, Wi-Fi and Bluetooth. Ukrainian Defense Consulting's programmers have created an easy-to-use software package which incorporates all relevant firing table data and provides an interface with meteorological data supplied by a dedicated weather station, in this case a 110 WS-16 unit made by Novalinks in California, additionally equipped with Bluetooth. The UBC can also be provided with muzzle velocity data from any standard chronometer, which will ensure accurate calculation irrespective of variations in round quality. The program uses progressive approximation methodology as its algorithmic base, which has been shown to improve accuracy to target between 20 and 40 meters. And the instantaneous availability of firing data means that adjustments can be calculated with each subsequent firing in a few seconds, something that could never be achieved using manual calculations. Input is simple and straightforward and covers all the required variables: grid reference data for gun position, observation point and target, plus meteorological data, either automatically or via manual input, plus muzzle velocity data if available. The program calculates and offers optimum settings for the charge and fuse type, and can provide output data according to whether the sight calibrations being used are NATO 6400mm or Warsaw Pact 6000mm standard. Positioning data can be provided in either the Western UTM cartographic system or Eastern SK42 format, as required by the user. Looking at the program in detail, the first thing that is apparent is that the menu and input options are displayed in a clear format which will be instantly familiar to any computer or mobile phone user. The handheld uses touchscreen technology and all pages are accessed via a name tab at the base of the screen. The first page is the group gun position (GP) data, and this requires the following data: grid coordinates for firing position incorporating X and Y axes together with height. This YXH data can be input manually or can simply be downloaded from the unit's own GPS. A name for the battery position in alpha or numeric, MD or main direction of target expressed in MIL, 6000 or 6400 format. In Western artillery practice this is normally referred to as the center of arc. DVO, muzzle velocity deviation, temperature of charge in degrees centigrade, round weight deviation QC, and finally ridge data expressed either in polar or grid coordinates. The next menu page is for meteorological data, which can be input either manually or automatically from the weather station. This data consists of P for pressure, T for temperature, W wind speed, and AW wind direction. If connected to the weather station via Bluetooth, this data will automatically update on the UBC once every hour. If there is no automatic connection, the unit will generate a reminder. After inputting or downloading weather data, the operator will then enter the position coordinates for the observation point, OP tab on the menu, in the same format as that used for the battery position. Finally, the target data is entered. This includes position data in either grid, YXH or polar format, the SLR slant range in meters, then angles from observation point to the target in mils, alpha for horizontal and epsilon for the vertical angle. Next, if required, YXH and polar combined input. Then the operator inputs the mission type: airburst, curved, mortar or illuminating, the shell type, HE, smoke, illuminating. This menu is dictated by the mission selected, again reducing the possibility of error. And lastly, the proposed charge, full or reduced 1 to 4. Once the data is input, the operator simply presses the Fire tab and all the necessary settings are displayed together with any assumptions the system has made in respect of data not entered. In the event of vital data not having been entered, or incorrect data input, the system displays an error message identifying the problem. The output data includes all parameters necessary for firing. The optimum charge setup, shell type, angle of deflection between center of arc and target, given as additional turn, quadrant angle setting, referred to as aim, igniter or fuse setting, DYN, elevation height per 1 mil setting, TC, time to target, and DXPR, horizontal distance setting per 1 mil setting. All reported data can then be saved for reuse or for training purposes. The whole system, computer plus linked weather station, was tested in November 2008 at the Yavorivsky Artillery Training Center in western Ukraine, with a total of 70 rounds being fired in 9 different mission calculations. Although no muzzle velocity chronometer was used in the test firing, the system was extremely effective, recording 100% of rounds within 20-meter radius of target. Also, Bluetooth data transfer between the weather station took place without problem at 50 meters and was normally effective up to 100 meters between the two units. The air temperature during the test period was between -1 degrees C and 10 degrees C, although both the UBC and weather station units are certified to operate well beyond this range. During the test firing, 5 people were trained in the use of the UBC, 1 artillery officer and 4 cadets. Total training time was extremely rapid, no more than 15 minutes. Ukrainian Defense Consulting believes that this system meets the needs of any artillery division where firing calculations are currently carried out manually. It is simple to use, highly effective in operation, and provides an inexpensive solution to both the training and rapid deployment of gun crews. The incorporation of muzzle velocity data also makes it possible to use ammunition which may be older or of variable standard as a consequence of storage in less than perfect conditions. Although originally developed for the D30 122mm howitzer, the system is currently under modification to be used in conjunction with the 82mm mortar, and this will be followed by further modifications available in first quarter 2009 to cover a range of weapon systems including 120mm mortar, 2S1 122mm self-propelled howitzer, 2S3 152mm self-propelled howitzer, and 122mm Grad unguided rocket launcher. The system can be modified easily to convert menus and output to any required language, with operator facility to switch between different languages as needed.